Alright, pre-algebra, we are on our final chapter, or section of chapter 6, indirect measurement. So all of our proportions and similar figures kind of accumulates to this as kind of a cool unit because we can use similar figures to measure things that are normally hard to measure. For instance, if you want to measure the height of a pine tree, it's very tall, you don't want to climb it, kind of prickly. I've climbed a pine tree before, not fun. If you don't want to climb it, then you have this option of using indirect measurement. So let's see what that looks like. So first of all, what is indirect measurement? Well, it's a measurement that allows you to use properties of similar triangles to find measurements that are difficult to measure directly. So like I said, height of a pine tree, how tall the school is. I mean, you can probably get up there, but it's not going to be easy because you'll get in trouble. But we can use shadows, we can use similar triangles to find this out, and we usually use triangles to do this. So let's look at real world example ones, and all these will be real world examples because we can actually use this. One year we went out and measured the height of the field goal posts, the flag pole, using indirect measurement without actually climbing up to the top of the field goal post. So that's just some ways we've practiced doing it before. So here we have this statue, the Korean War Memorial. At a certain time of day, it casts a shadow of 43.5 inches, and a person standing next to it, which we can easily measure to be 64 inches tall, or 6 feet 4 inches. We don't know how tall that statue is. If it casts that shadow, and this person that we know the height of casts this shadow. So we've done proportions before. We kind of pick the size that match up. So there's two ways I've seen the students do this. I typically do, the height over the height. So here's the height of the statue. Here's the height of the person. So the height of the statue on top of the height of the person. And that's going to be proportional to the shadows. Well, the shadow of the statue compared to the shadow of the person. And I have to do the 43.5 on top here because I chose the statue to be on top of this one. And that's 32. The other way you could do is look at them as just triangles right here. The h and the 43.5 are in this triangle. So I could do h over 43.5. So put h over 43.5 because that's in that statue triangle. Now if I look at the, I guess I'll call it the human triangle, the human in the shadow, I'll put 64 over 32. Alright, now if you notice, we solved both of these proportions by cross-multiplying both situations. I'm doing h times 32 diagonally to get 32h. I'll put that up here. If you look at this one, I'd multiply 32 times h. And then if I go the other way, I'm doing 64 times 43.5, which gets you a large number. But the reason I wrote this one here is because some of you might see a little shortcut by doing this one. It doesn't always work this way. Sometimes this way works better. But if I look at this one, the 64 I know is double the 32. And so I know my h over here on top is going to be double the 43.5. So that's kind of the shortcut. I'll come back to that in a second. But if I cross multiply 64 times 43.5, I get 2,784. And then to solve this equation, I divide both sides by 32. Divide this by 32. And I get h equals 87. Which again, if I did the kind of the shorter method, or if I saw this pattern down here, I would say, double that, I'm going to get 87. Alright. Just double check to see what the book said we got. Make sure I did it right. Yep, h equals 87. And again, that's kind of the shortcut talked about down here. Let's do one more. Here they kind of use indirect measurement to measure across a lake, something you don't want to necessarily swim across because it'll take a lot of energy. But they measured some distances on land to kind of use similar triangles to find the distance across the lake rather than swimming it or walking around it. But the way these triangles match up, again, I have the smaller triangle here and a larger triangle. Okay, so there's a couple ways. They have this proportion. I'll write both proportions you could do. Let's look at the triangles here. I have 10 and 20. So let me put 10 over 20. And now I have my large triangle of 16 and x. So I ask, do I put 16 over x or do I put x over 16? Well, look here. I put 10 over 20, so I put the shorter side on top. So in this bigger triangle, what's the shorter side? Yeah, 16. So I put the shorter side over the longer side. Okay. And then I do 10 times x is 10x. 16 times 20 is 320. If I divide both sides by 10, ran out of room there, divide by 10, I get x equals 32. And again, the shortcut is, you kind of notice here, 10 is half of 20, or 20 is double 10. So my bottom number has to be double my top number, because it has to be proportional. So 32 is double 16. There you have it right there, x equals 32. So it saved us the trouble of walking or swimming across this lake or pond, and we kind of stepped off proportional triangles here. 10 and 20, x and 16, or 16 and x. Alright, so indirect measurement, very useful. I've used it multiple times when I do construction in the summer. Very helpful in measuring things you don't want to actually climb up, or in this case, swim across. Alright, so have a great day, and we will kick off semester 2 with some indirect measurement.